All right, let's go ahead and get rolling. First of all, welcome everybody. This is the Austin API Meetup. Is everyone in the wrong place? Okay, fantastic. That's a good sign. First of all, you found us. Congrats. Some quick and easy ways to find us online. We are Austin API on Twitter. It's a good way to keep sort of a heads up on what's going on like in this community and the larger API community. We tend to spread like news, interesting stuff that's going on, prominent people in the community, that sort of thing. If you go to austinapi.com, that redirects to our meetup page. So if you meet somebody and you're like, wow, there's this great meetup, which hopefully you will say that by the end of this, and you want to share the news with somebody, it's austinapi.com. It's a quick way to sort of get people connected. Quick intros. I'm Keith Casey. I'm one of your fearless leaders here today. Damon Clinkscales is not here. He is tweeting or sending pictures of Legoland to me, taunting me this week. We've got Jason Harmon in the back, pronounced Jason. All right, people got it. Fantastic. And who's our beverage sponsor this month? Nobody. Okay. So we usually have a beverage sponsor of some kind. We have beverages, so that's the important part anyway. Some quick calibration questions. We really like having an idea of like who's here, who's in the community and stuff. Who here works for a company that predominantly builds APIs? Okay, a handful. I'm one of them. Okay, who primarily uses APIs? Okay. Who doesn't know what an API is and is just figuring it out? Come on, there's always a couple. No harm, no foul. Okay, no problem. We really try to set this meeting so that people can sort of wherever they are on the spectrum, whether they're just getting like figuring out what APIs are, whether they're designing and building APIs for major companies, or whether they're just dorking around with it, seeing what they can do. We try to make sure that there's something here for just about everyone pretty regularly. Another quick show of hands. Chosen technology, Java. A couple Java people, C#, Microsoft in general stuff, PHP. Python, Node, Clojure. All right, I knew we had a Clojure guy. What else am I missing here? Ruby. Nobody. Wow. Damon also runs the Rails group, so it's good that he's not here tonight. Feel the shame. Let's see, what else did I miss? Any other technologies? Who doesn't code APIs but works on the stuff around APIs, like developer experience, documentation, what else? Okay, cool. Handful of people, fantastic. Let's see, now we do have a couple private announcements. What I'm about to share in the next 2 minutes can't be tweeted until tomorrow, okay? That agreement? We've got no fingers crossed, everyone's... Okay, so the next API Strategies and Practice Conference will be here. That's public knowledge. It is falling November 18th through 20th over at the Sheraton at 11th and Red River. You guys know, like the big tall building that's a Sheraton on it, that's the Sheraton. So it will be here. It's about 400 people. They do it all over the world. The last few places have been Berlin, it's been Amsterdam, Chicago, San Francisco. Jason and I have both spoken. Your seats. Now that I'm calling you out, please feel welcome. But the contract is being signed like today or tomorrow, so please don't announce anything until like sometime tomorrow afternoon, okay? But one of the things we're looking for is I'm the local conference chair, helping put this whole thing together, and we're looking for volunteers. So if you're interested in like being some on-ground support and probably getting a free ticket, well, I'll confirm that like shortly. It's a quick and easy way to get it. If you're looking and you've been wanting to go to an API conference for a while, this is a cheap and easy way to do it. You don't have a flight, you don't have a hotel, your meal ticket is pretty cheap. You basically spend like beverages, whatever beverages you prefer, and the conference ticket itself, so it's a pretty good deal. Let's see, Jason's also serving on the committee with me, bringing stuff here. So that means in just a few days, they'll announce their call for presenters. So if you're interested in presenting on something you've learned, whether that's a tool, whether that's a concept, everything from API security to IoT stuff, to logging, to developer evangelism, to whatever the piece is, like they're actively looking for stuff to fit into that. Let's see, anything else I need to cover? Okay, and with that, we'll go ahead and hand it off. Janelle is here talking about developer experience, which I think is just freaking awesome. Who does like developer experience stuff here? Okay, there's a few of us. It's hard to do, and it's hard to do well. Like going off gut instinct sucks, and so she's here to give us a framework to do it better. Please, take it away.
Getting me some water, please. All right, so hi, I'm Janelle Klein from NewIron, and for those of you who who don't know who we are, we're a software niche recruiting shop in town run by software people. So it's a little bit different in that we aren't vultures. So please don't throw tomatoes because I work at a recruiting company. It's a really awesome place. So, what I'm here to talk about today is an open standard for learnable APIs. So when people think about standardizing something like this, and they look at this metric that I have here of easy to use and hard to use, and trying to put a number on that. So I want to let you know too that I'm not measuring the code in this case. I'm actually measuring the experience with the code. So this is a usability metric as opposed to a code metric. So I've been studying human factors in developer experience for about 8 years now and writing a book on this topic for the last 4. And so I'm going to show you guys a strategy for potentially solving these problems. But my goal tonight is really to start a conversation and to get the community kind of talking about and thinking about how we can solve some of the biggest challenges facing our industry as a whole around the growing complexity and safety risks in the software supply chain. So that's really what we'll be talking about at the end of this. So first, we need the slide thingy to be moved.
So you were not the first person that's had this problem in this room. Like almost every presenter I've seen in this room has theirs pretty simple.
Okay.
Are you connecting over Apple?
No, I'm not.
Play?
Actually, I directly connected, but my laptop is frozen. Wait, there.
Oh, there you go.
It did something. Guess. Okay, so clicking seems to work. Well, that works. So, all right, as long as I don't need to go back, we're okay. So, my last slide that I just passed said what? Do you guys remember? All right, awesome. Thank you for reminding me. So, why should you care? So first, let's talk about the modern API decision-making process. So let's say we've got a question on our mind. We want to build a new contact, or we need a contact management API as a component, right? So what's the first thing we do? Anybody?
Google contact management.
Right? So we go to Google and type in contact management API. But then what happens?
Stack Overflow.
Well, so I pulled this from Programmer's Web, but our API directory now includes 63 CRM APIs. The newest is Ping Giant API. The most popular in terms of mashups is Salesforce, and there's 44 sales mashups, and here's the list of all 63 for you to go and explore. And so then we spend a few hours looking around at Stack Overflow, reading documentation, trying to find blogs about comparisons on things, and then we have to make a decision, right? But we never quite have the information that we need to make a decision yet, and we're still kind of looking at all this stuff, and it's overwhelming, and we really can't make a good decision, so what do we do then?
Cut and paste.
Pick one.
Well, picking one is certainly an option. This is usually the more common solution I see is ask your friend, right? Hey, George, which API do you use? And so George says, well, we made our own Salesforce mashup. Here's the link for that one. So you're like, okay, thanks. I'll use that one too, I guess, right? So a lot of times this is the state of the art in terms of modern component decision making. And this is kind of the best we can do with the information out there in a lot of cases. So, but this is just, a minor annoyance in the scheme of things. But the real pain kind of happens later. So did any of you guys go to DevOps Days in Austin a little bit ago? Anybody? Come on. All right. So at DevOps Days, Josh Corman gave this incredible talk about really taking a supply chain approach. And it was, if you've ever heard this guy speak, I put a link to the talk here that it's definitely worth watching. But he's one of those people is frightening to listen to. I mean, just with respect to impact of things. So he comes from a security background, But he put together a actual strategy for how we could go about conquering these problems, but it requires people work together, which is sort of the overarching barrier to success. So the talk at a summary level kind of goes like this. So software and connectivity, we're putting in everything. Software is infecting the world in his mind. As coming from a development background, I don't necessarily think about software as an infection, but I can kind of see that approach from a security standpoint. But we're putting software in our bodies, in our homes, in our cars, in our infrastructure, and the implications of this are really frightening. I mean, we've got software running nuclear facilities, and all this stuff is like connected to the internet. And he was talking about cars that had like 100 million lines of code in them. Just let that sink in a minute, of a car running 100 million lines of code. And to top it off, if you hack the stereo, you can get access to the steering wheel and the brakes. 100 million lines of code. So he works at Sonatype, which produces Nexus, and so he's got all these amazing stats on what people are doing in terms of component libraries. And 90% of our software these days is assembled from existing parts. We don't build software anymore. We go and find a library, we go and find an API, build mashups of things and glue it all together. We're integrators, right? And we take this giant pile of stuff and then we poke at it a little bit and assume that we understand it, and then we ship it to production. And we'd like to think that people that have more security concerns around their stuff would put more time and energy into quality, but we all have these same challenges with this big giant amount of complexity and functionality that's required to build the functionality. And so there's no real way, those developers don't actually understand that stuff that they're putting into medical devices and cars and these things that become a safety concern. And these quality problems and security risks in our applications are a consequence of this complexity and risk essentially building up in the supply chain. So bad software you can think of kind of like environment pollution. And as these bad components get built up in our collective software supply chain, the costs and the risks start affecting everyone, right? And you're going out and looking, trying to find what's out there that you can use that isn't going to cause a problem. But now we've got this shared dumping ground of just all this crap that's out there that we have to deal with now. And have you ever had like a shared module that nobody really owned, and it was kind of like the thing that was the dumping ground for everybody, but nobody had control to fix it, and so it just turned into this giant mess? And that's kind of what's happening in our industry, except at a larger scale. We've got this kind of shared, component across the industry, if you will, that becomes a shared dumping ground for everybody's crap, but it's the software that isn't yours, so you can't really do anything about it, but nobody can. And so we just kind of keep following the same pattern, and nobody takes ownership of the problem. And with the security implications, with software and connectivity being put into everything these days, that the risk to public safety is ultimately on all of us. And so Josh actually proposed a solution to this problem. So do you know who this guy is? So this is Edwards Deming. So he's credited as being the father of lean and agile and all these processes that have revolutionized manufacturing, but also revolutionized the software industry. But Josh pointed out that we've copied everything from Deming's manufacturing ideas except for the quality and risk management practices. So supply chain management, process control, like these are the things we haven't figured out how to map to software. And so we just kind of operate off gut instinct a lot on what good is. And if you've ever met a software developer that has very orthodox views in the world of what good is, and we get in these almost religious debates about what is right, what is up, because we don't have a way to measure what really matters. It's all these kind of invisible factors that we have to learn to deal with. So what if we started managing supply chain and process control in our software processes? So Josh is with let me back up a second. So our first generation of solutions we came up with was in the CI space, and we learned how to integrate more quickly and avoid a lot of problems. And then we had the DevOps kind of continuous delivery era, and we learned how to be a lot more efficient. But Josh is supposing that third generation is essentially building those quality management practices into the process and actually taking a supply chain approach so that essentially everybody has common ownership of working together to solve the overall supply chain problems and taking the costs out of the supply chain. So to conquer those challenges of quality and risk, we really need to manage the quality in the overall supply chain. Does that make sense?
What are some of the elements in the supply chain that you're referring to?
So when you're choosing a component, for example, so when I think of APIs, I mean I know it's generally used in the context of remote APIs, but essentially you've got a library. It essentially has an API too, right? So we've got remote APIs and we've got local APIs, but they're all just components. And so what I'm talking about is of the supply chain is all of the components that ultimately get stuffed into our application. So being able to manage the quality of all of those parts that you don't actually own, but you're dependent on. So Josh took this one step further because he went and a few years ago tried to look around and find the adults that were working on solving these problems because it was becoming more and more of a security concern. And as he was looking around for the adults, he realized that he didn't find any. and that in order to solve these problems, nobody's coming to save us is essentially this message, is the cavalry isn't coming. That this is it, we can either sit here and wait for the roof to cave in on our heads, or we can start learning how to work together and do something about it. And with a problem like this, you can see the system kind of spinning out of control. But in order to fix it, it's like everybody's got to come together and do their collective part to do something about the problem. Anyway, so really, I guess what I'm proposing is really taking ownership as a community of the supply chain problems and designing the future we want. And what do I mean by design? So when you zoom out and take a look at the bigger picture, instead of software problems, you essentially have human system problems. But one of the things I found in my work is, as I was starting to work on human system problems, I realized, hey, I can apply all the same things I learned in software development about good design. And if we can leverage that problem-solving knowledge in the human system domain and learn how to manipulate and move human systems, that the software community could actually be the greatest problem-solving community in the world to go out and start tackling the world's problems. So really, I'm talking about making a deliberate effort of designing human systems, taking into account that there's always costs, there's always consequences, and open doesn't equal good, in that competition serves a very important purpose in the overall system, just like having shared standards and things do. So private competition, we have this survival of the fittest effect. You've got self-optimization, which spurs creativity and innovation. So there's places where we want that kind of competition because it drives the industry forward as a whole. Open standards. So standards give us the ability to define the competition. So it's more targeted at optimizing the system as a whole. So it becomes a matter of public debate as opposed to something that is privately done for personal incentives. It fuels empathy. We can look at what everybody's problems are and figure out how to solve them together so we're all a lot happier. And these two systems essentially interact to produce the overall behavior of the system. So if we take ownership of evolution, and let's say the system, like the software industry, is this ball that we're trying to move. Essentially, to move the ball, we need to push the ball. So one of the things that you can do to push the ball is with pain. And essentially, pain in the software industry is the threat of survival. So we can do things that threaten the companies that are producing crap, essentially, such that there's a selection force for producing better stuff out there. And likewise, on the other side, you've got opportunity. So opportunity has a pulling effect, but essentially it's the path of least resistance. And so by taking a deliberate effort in designing what that path of least resistance is supposed to be, we can kind of work as a community to design how we want to move these forces and build a feedback loop that pushes the system in the direction we want. Does that make sense? I know that's...
So is the system the supply chain open source modules that you talked about, or something else?
Essentially that. So in that this applies generally in an abstract sense with any kind of human system, you could say. So if we want to manipulate the supply chain problem, we have to kind of look at how people are using things, what are their motivations in that system, and how we can kind of manipulate them. So specific example, so what if we had an open standard for learnable APIs? What would that mean? So the reason I chose this is that mistakes are primarily caused by a lack of understanding. And so learnability essentially measures the cost of understanding and the risk of mistakes as a whole. It's not a perfect metric, but we can get pretty close to capturing a lot of the overall costs of ownership that are really hard to measure right now. So let's go back to our scenario. I need a contact management API. So we go search engine and type that in. What if we saw something like this instead? Where essentially you'd have a cost of ownership analysis that was based on shared data that was available to everyone based on developer experience data, and you could do a comparative analysis of the APIs you were interested in and filter the data by the use cases that you cared about. So being able to enabling quality decisions at this component decision level creates selection pressures for quality in the market. So what kind of pressure? Is this like a pain pressure, or is it an opportunity pressure?
So do you envision the API as being distinct from the software that executes the API? Like the API is just being a kind of a standard, not necessarily connected to the commercial product that actually owns that, or what's your thinking here?
So the question is, let me see if I got this right. Am I thinking about the API as connected to the software, two separate things?
Yeah.
So in this case, I'm measuring the developer's experience with that particular API.
Right.
And so the API tag is essentially just a tag on that particular data that says this is data for developers using this particular API for this particular use case. So it's disconnected in that way, but it's representative of that software experience from at least the interface perspective.
Who gets to decide the criteria by which the different APIs are ranked?
I think that, so the question was, who gets to decide on criteria of how the APIs get ranked? And I think that's one of the main questions we need to talk about. So I was going to share my research with regards to how I'm measuring these things now, but my plan was essentially to make that an open standard that is debated by the community to figure that out, and if we do it wrong, we learn how to change it and we find a way to make it work. I don't really have a good answer to that, but that is why I'm here. So there's probably additional things too that would go into cost of ownership as well, besides learnability. So for example, whether the API has security patches, or there's other things that affect cost of ownership as well. So all of that, we could come up with some, standard, say, that would provide the information that we need to make quality supply chain decisions.
So you're making a comparison to APIs being sort of the next frontier of the way that we use software components through something like Sonatype now.
Yeah. So the comment was, we use Sonatype now for libraries, but this would basically be something equivalent to what Sonatype does, but in the API space to give us developer experience evaluation data. I would also add that I think this should be added to the Sonatype, library type information as well, in that you've got local APIs and you've got remote APIs. They're all, at the end of the day, components that we're shoving into our software. And then the next question is, what's the strategy to get there? So at the end of this talk, keep these questions in your head, because this is sort of the topic of discussion. So next I'm going to show you the research that I've been working on for the last 8 years or so with regards to how to build a metric like this. And then we'll come back to these questions on, okay, so how do you take that and get to the point that we could actually put together an interface like that? Does that make sense? All right. So this is the problem that I've been working on for the last 8 years is how to break the software rewrite cycle. So it's related in that a lot of the problems that build up in our code base and that we've been struggling to try and communicate with management and get more time to work on things. My software project I had that started this journey, I actually was working on with Morgan here, so I'm gonna tell this story. But we were trying to do all the right things, and we had CI, unit testing, and design reviews, code reviews, all that stuff that you're supposed to have, right? Yet still, our project slammed into a pretty big brick wall. And by brick wall, I mean we brought down production 3 times in a row and didn't ship again for a year. So I spent, I think we were working on it for like a good 6 months or something, trying to figure out what was going on with this performance problem that happened in production that didn't happen, locally and stuff was the first derailment. But the last time that we brought down production, it was my code and totally my fault. And I was a few years out of college, and I was just pretty arrogant, thought I could, re-architect the whole system my first 6 months on the job, came up with this grand plan, and then I shut down every single tool in a production fully ramped semiconductor fab, So this was like the humbling experience of my career. And after that, I was in, my one of the offices with my boss, and I was just a mess and crying at work and stuff. And he's like, well, you've got 2 options. You can accept what happened, put it behind you and try and let it go, or you can face the failure with courage and learn everything that it has to teach you. And I really took that to heart. So, I went home and brushed off my knees and came back to work the next day and was like, all right, we're gonna figure this out. I want to actually understand what caused us to go off the rails. So I built this tool that could detect, basically could compare all of our defect history and mistakes that were made with problem areas in the code. So I thought the problem was essentially there's technical debt building up in the code base that was causing us to make mistakes. And so if we made changes in the areas that had more technical debt, we'd be more likely to make mistakes, right? So when I looked at the data though, that's not what I found at all. And that most of our mistakes were actually in the most well-written parts of the code. And at first I was like, that can't be right. That's just wrong. Something must be wrong with my analysis. But the more I looked at it, what I realized was we made significantly more mistakes in the code that we didn't write ourselves. That our mistakes were mostly correlated with lower familiarity. And I knew there had to be more to the story though, because that just didn't seem like enough of an answer. Because this is what I knew. So when I worked and interacted with complex software, it was really painful. But what made development actually feel painful? And so I started keeping track of all my painful interaction with the code and keeping track of it on a timeline like this. And the pain started when I ran into some unexpected behavior and was resolved when I found the cause of that problem. So that was 5 hours and 18 minutes of troubleshooting time. So I think everyone would agree that's pretty painful, right? So the amount of pain was driven by 2 factors: the likeliness of unexpected behavior and the cost to troubleshoot and repair the problems. So then I started categorizing both of these things. What were the causes of unexpected behavior and the things that made troubleshooting more time consuming? And as I wrote down all these categories that I kept running into in experience, I found that most of the pain was actually caused by human factors. So for example, similarity mistakes. This is something that happens a lot with API development, is we make assumptions about how things work based on things we've interacted with in the past. And so then when we work on something and it doesn't behave like, this tool we used before, we make bad assumptions about it. Another example is ambiguous clues. So this comes up with experiments, and we'll have a clue that essentially can have multiple possible causes, and we'll make a bad assumption about which of those causes it is, and down the rabbit hole we go, right? And that makes troubleshooting really time consuming. So friction occurs in the context of a process. So it's not like something that's inside the code. And pain is caused by high friction movement from point A to point B. So we've been trying to identify like some noun or thing that's inside the code, but all of these effects occur in the context of a process. So once I sort of shifted my mind around that process metaphor, suddenly all these things became visible. So IdeaFlow is this metaphor I use for thinking about the human interaction between the developer and the software. So think about ideas in your head flowing into the software. So you're like molding the code like it was clay to represent the ideas in your mind. And these visualizations, I call these IdeaFlow maps. So the IdeaFlow process looks like this. So first, we're working on some code and learning what it is we need to do. And then we make some changes. Now we have to validate it, right, and see if it works. So at that point, one of 2 things can happen: confirmation or conflict. So confirmation is kind of like walking down the stairs and everything feels okay, right? Conflict is that detection alarm that goes off in our brain that something's out of place. It's that same kind of feeling you get when you're walking down the stairs and one of the steps isn't where it's supposed to be. Suddenly everything in your brain is paying attention to that moment. So we have that same kind of reaction when we see things unexpected in the code. And that sends us down this troubleshooting cycle. So friction occurs in 3 places in IdeaFlow: troubleshooting, learning, and rework. So I associated with these with 3 different types of pain. So troubleshooting pain that we already talked about is driven by the likelihood of unexpected behavior and the cost to troubleshoot and repair the problems. Learning pain is driven by the likelihood of working with unfamiliar code and the cost to learn those things. So learning pain is driven by things like having lots of third-party libraries, more complex frameworks, a really large code base, a high turnover rate. All these things can cause extra learning work. Rework pain is driven by a likelihood of making bad assumptions and then the cost to correct those decisions. So things like bad assumptions about the architecture or design, bad assumptions about customer requirements, and the longer we delay before correcting those decisions, the greater the amount of rework. Does that make sense? All right, it's good, because all right, so what I did with this is essentially turned it into a learning framework, or a feedback loop, really. So once I was able to visualize the effects of developer experience, this turned into my mentorship technique, essentially. That I have 3 steps. Make the pain visible, understand the causes of pain, and then improve decision habits. Essentially, I'm walking through this process of creating visibility and clarity and awareness. So visibility is essentially making these developer experience charts and realizing, wow, I just spent 8 hours troubleshooting that problem and the time just zoomed by. If you've ever had that experience, a lot of times we have no idea how long we spend on these things because we're just so like laser focused on what we're doing. And since troubleshooting and solving problems is kind of fun, that we don't always have like a natural association with calling this pain. So I'm trying to build in that pain reflex such that it triggers our kind of threat processing engine, if you will, of like all of these things that eat up all of our time. If we call them pain and start thinking of them as pain, then we can start talking about how do we make development less painful. So clarity, what I'm doing in the learning process here is essentially pattern recognition. So all of those types of patterns, I'm creating patterns of problem types, of strategies, of different situational contexts, and putting it all together into a collective decision model, and then working on deriving decision principles. So at this point, I've got 7 decision principles clarifying essentially the art of software development. And then improving decision habits, I'm using a checklist system so that you kind of end up having hindsight bias problems where you kind of look at something that happened and went, oh, that's kind of a dumb thing to do. I should not do that anymore. But we work in the same way for so long, it's really hard to actually change our decision habits that end up affecting those results. So instead, I started asking, what question could you ask your future self in some particular moment to remember this, lesson? What question would that be? And I started building checklists of questions to sort of shift or implement your own learning and decision-making improvements. So that's kind of a quick overview of this is more the direction my book is about. But the tools for IdeaFlow Mapping are open source. I've only got one version right now in IntelliJ, but so sorry for non-Java people stuff out there. It works in IntelliJ in general though. So there's buttons for troubleshooting, learning, rework, and event notes, and you can change the task, and all the data basically goes into these visualizations. So one output is the visualization itself, and then you can zoom in and see the details of all the files you've been looking at and what you've been modifying intermixed with it. So you can pick up some interesting things, like for example, I can see if I'm bouncing between a code thing and a test versus I'm spinning up the application to write some code and spin up the application. So you can see those kind of effects in the developer's activity. And then if I click on one of the time bands here, you can kind of zoom in and see the details. So in this case, the conflict was, why isn't the token showing up in the URL? And then when I solved the problem, I discovered there was a typo in the email template, and that took me an hour and 8 minutes to track down. And then I'm tagging these things with problem tags. So all of those categories and patterns, I'm working on kind of building a pattern language for describing developer experience. So I've been doing this for a while now and have a whole lot of patterns. Like this was actually my first book that I ended up scrapping and turning it into another book. I still have all the stuff, but that's another story. I'll tell you next time. Anyway, okay. So we can learn to read these visual indicators that you see in the IdeaFlow maps. And one of the things I realized is that all the IdeaFlow maps kind of look the same. And that similar to how an EKG helps doctors diagnose heart problems, IdeaFlow maps can help developers diagnose software problems. And essentially what I was recording, the heart of software development, was problem solving. The heart of software development is this kind of problem solving machine. So I started looking at other research out there on problem solving in kind of the cognitive science space, And I cobbled together a variety of different problem-solving task models and came up with something that looks kind of like this. So first thing we do is evaluate what are all the possible alternatives. And then we build a concept and decide on kind of a general strategy of what we're going to do. And then we build a conceptual model of how the code works, kind of scan through the code, look at things, build a model in our head of how all the pieces fit together. And then we go into this feedback loop phase where we keep refining the details and poke at things and see how they work. And we fill in the details of that mental model. And sometimes we run into what I'm calling a strategy conflict. Essentially, we discover our strategy, and then we go back to the drawing board and start over. And when you break things down into subtasks, essentially you see a composite, pattern of, you zoom in to a smaller problem and kind of repeat that same process. So there's like the big problem, and then there's like these little problems. So what I found is that depending on where the disruptions were in the problem-solving process, you'd see a different effect in IdeaFlow. So if there's problems with evaluating alternatives, essentially you get this, what I call a tumble pattern, but it's essentially trial and error. This is what trial and error looks like. So the red in this case is the strategy conflict, where we first realize, oh, my strategy is not going to work. And then the blue is, okay, well now I need to find a plan B. And then the yellow is trying out plan B. And then another strategy conflict is, oh, plan B is not going to work either. And so we go through this kind of looping process of trial and error to try and, kind of shove the box in different ways until we find a way to make it fit. So if I saw patterns like this, I'd ask questions like, how did you evaluate the possible options and choose a strategy? What was wrong with the different strategies you tried? What was the discovery that made you choose a different direction? So problems with modeling. So this is basically spending a lot of time figuring something out such that you can, go and make progress. So this is all learning time. And these red bands are essentially unexpected dependencies that you run into before you have actually written any code. You're still trying to, formulate your plan. And before you write code, you oh wait, that wasn't what I was expecting to be there. And so you end up going down these resolution paths to resolve those kind of problems too. So if I saw patterns like this, I'd ask questions like, were you working with something that you were unfamiliar with? Did you run into code that was noisy, ambiguous, or misleading? What do you think made it difficult to learn? So with refining, this is when we get down into working with complex details. So as opposed to like these high-level patterns with figuring things out, you see learning start to become part of the validation cycle. So how we get into a rhythm of write a little code, see if it works, work out the kinks. And when we're in the midst of that cycle, when the code is really complex, you see this kind of strafing pattern where every little bit of progress, we're like, okay, got to figure out this next part again. And it's, there's a lot more thinking involved in the details. So if I saw patterns like this, I would ask, did your task involve changes to complex code or business rules? Were there a lot of details that you had to keep in your head? What was causing the complexity in the validation cycles? Problems with the validation cycle. So this comes up when it's difficult to get feedback from running experiments. So you can think of all the things that make it hard, to get feedback, and you poke on something and troubleshooting problems. So this is probably the one that most people run into. But in this case, I'd ask, what experiments did you run to troubleshoot the problem? How many times did you run the experiment? How long did it take you to get through each experiment cycle? So with this kind of data, you can start to get a feel for what's actually going wrong in the experimentation process. So one more, problems with execution. So I'm a back-end developer, and this is what it looks like when I code in JavaScript. That essentially changing the code itself is highly mistake prone, and I don't want to blame JavaScript because I know that some people out there are much better at this stuff than me, but I find that that with JavaScript, I have to keep a much tighter leash on things in a way in order to like write a lot less code and much tighter iterations for troubleshooting not to get out of control, because the mistake frequency is so high, so you have to kind of manage it differently. At least it's high for me, but like I said, it might just be because I'm not very good at JavaScript. With this, I'd ask, was there something in the code that made these changes especially mistake prone? How familiar were you with the language and tools you were working with, which I think is part of my problem? Were you tired or distracted when you did the work? The other time this comes up a lot is when developers are working when they're tired, you see this noticeable spike in mistake frequency. This is why you should go home at the end of the day. So at that point, I ended up starting to categorize the problem types that I was tagging into categories according to the problem solving model. And I came up with these 10 pains of software development. And for time, I decided not to go through them, but essentially you can see there's things that affect the validation cycle, like experiment pain that we're talking about of just difficulty running experiments. Alarm pain is essentially test maintenance problems where you're spending lots of time troubleshooting because you have all these tests you have to troubleshoot that just failed and you have to put them back together again. And so test automation is becoming a huge developer experience burden, but there's a lot of folks out there that are just tunnel vision, gotta have 100% test coverage, and they're destroying the developer experience aspect by creating all of this pain with test repair. You guys know what I'm talking about?
And what would your alternative be? Just no testing?
I think smarter testing, and in that one of the things I've found as I started doing this, unit testing, for one, is really crappy regression mechanism I found in most cases, in that it's extremely helpful when you're writing code to begin with and keeping tight control, but filling in unit tests after the fact, complete waste of time. The other thing is I write a lot more tests around invariance. Like, for example, if you have like a read-write operation, writing like a symmetrical test that goes across both of them as opposed to testing each unit independently. And the goal is to try and, when you make a mistake, is to figure out how to detect that mistake and let the developer know. Other cases, you can design the mistake proneness out of the system such that you don't necessarily need a test for it. Removing a lot of unnecessary complexity can go a long ways too. So I think there's a lot of other strategies for solving these problems. We've also done a lot of work with things that are not tests, like for example, building a state controller that you can basically bypass the back end of your application and be able to load the front end of your application in any state, be able to have diagnostic views so you can see kind of internally what's going on the inside of your application while you're working. Like there's all kinds of tools that we can build to make experimentation easier that aren't necessarily tests. And I think if we think about it as an experimentation problem, that we're a lot more likely to come up with solutions that make sense. But it's like once you have data that says this is a pain point, I think the problems are actually relatively easy to solve. It's just that we're trying to solve them without understanding them. And once we understand them, it's like, oh, I know how to fix that. So I think that's the bigger issue, is the lack of visibility. So even cooler though, when I started aggregating problems this way, is we started adding up friction by pain type and making charts kind of like this. And whereas in most cases, you can't really aggregate data together in that, across tasks, because it's all this miscellaneous stuff and people try to do it all the time and you just get a bunch of meaningless output with these aggregates. But since every task is a problem-solving task, you can aggregate problem-solving, pain across tasks quite meaningfully. And one of the things I've found is that when a developer tends to create code that has experimentation problems, they tend to create lots of code that has experimentation problems. And so since the problem-solving pain is more of an effect of decision habits. You tend to see a lot of commonality across experiences as an effect of the particular decision-making habits of the team. So the cool part is with focused improvements, i.e. we work on reducing experiment pain, you actually get visible, feedback that, hey, we're improving, which we've never had visible feedback before in software development. So being able to drive improvement at a team level this way and see things like, for example, I wrote this code and I think my code is easy to understand, but then when you try and use my code and integrate it into something, you have all these problems. We can actually have a conversation about that as opposed to who's going to win, who's right, And instead it becomes an objective problem of how do we reduce friction across the entire team. So what's causing the software rewrite cycle? So once I had visibility and could see these problems, I started collecting data on different projects. It's pretty fascinating. So essentially, the driving force is this cycle of escalating risk. So under the pressure of constant urgency, combined with a lack of visibility, we've got this feedback loop that just kind of the pain builds up. So we've been calling this technical debt because we feel this pain building, but I don't think the pain is actually caused by the things we generally think is causing it in most cases. So first we kind of ignore the risks, usually because we don't see it. And then we're increasing steadily the likeliness and magnitude of pain. And then there's more frequent bugs and higher task effort, which feeds the time pressure, which adds this cycle. So we keep compromising and making high-risk decisions, and it steadily becomes a habit. So I've got 3 case studies here. So this first one is a healthy project, about 10 months old, so where we made a deliberate effort to reduce troubleshooting time. And the data kind of looked about like this. There was 10 to 20% friction just from normal everyday troubleshooting when we had a deliberate effort to stay focused on this. So case study 2, this was a thrashing project about 18 months old where the team was trying to hit, I guess I never described what thrashing meant, but that's okay. Anyway, I'll tell you right now. Essentially, thrashing is when you end up with more problems that you're spending time on than actually progress. So what was happening with this team is they had this rewrite effort they were doing to replace their existing platform. And they were in this battle to hit feature parity with tons of feature pressure and from product to get all this stuff done so they could put something in production. And with all the feature pressure, essentially, they were screaming about wanting to fix all these problems, but didn't have time to do it. And when I did some measurements on the data, they were spending about 40 to 60% of their time troubleshooting problems. What was interesting is with all the pain and the noticeable productivity slowdown, management gave them time. They had like 3 months that they gave them to work on nothing but making improvements. But the things that they fixed had that technical debt lens on them. They essentially didn't fix anything that would have had an impact on these problems at all. So they spent 3 months essentially working on improvements that didn't make any difference. So they have the same problems, the same pain, and without visibility, this is kind of what happens. We don't really know what to fix. So, third case study, this is what I'm calling a post-meltdown project, where essentially all of the original developers had left. So there's a knowledge vacuum here. And this is what it looks like when you're spending 90% of your time figuring out what to do and then tweaking that one line of code. So the interesting thing is all 3 of these case studies, all of these tasks were between 1 and 3 days. And so we've been trying to see these effects by measuring like velocity and task lead time. But you really can't see it unless you look at what's actually going on during that time. All right, so remember this with, copying Deming's manufacturing ideas, right, of supply chain management and process control. So my background is in statistical process control and supply chain and manufacturing. So when I looked at these problems, once I had a handle on how to like measure and quantify the pain and the risk of those things, I basically built a software control system. It's exactly what this is. So all of these things from, you know, manufacturing context with giving us traceability of those problems, you know, we can, once we have the system for visibility, we can apply the, you know, entire knowledge base that's come out of manufacturing with process control and traceability and all this cool stuff that we have had no way to map to software. Suddenly this is like, you know, the missing link that lets you apply, you know, what, 50 years of knowledge in this stuff. It's huge. So my learnability metric is essentially the average friction across a specific set of developer use cases. It's kind of what I'm proposing for the metric. So now that makes a little more sense what that would mean. So the discussion is really, though, how do we get there? So first thing is, you know, what information do we actually need to make quality decisions? Thoughts?
How long it takes to build a Hello World app?
How long it takes to build a Hello World app?
How long it takes to build a non-trivial app?
How long it takes to build a non-trivial app? So I had, I've generally found in measuring like the overall duration of time that things take to, the nice thing about measuring like negative time, the time that we're not making progress, is it's much easier to look at meaningfully in aggregate, I find. Like the things that are slowing you down, like quantifying those things as opposed to the time, the opposite of that essentially. So I feel like in some respects, I'm like trying to measure the inverse of what you're proposing.
Could you data mine Stack Overflow somehow? Like especially unresolved questions.
So could you data mine Stack Overflow? Maybe. Do you have any ideas on?
Yeah, don't really know anything about, you know, like especially if you could, it might be manual, but you know, count like questions that couldn't be resolved.
API-related products that actually have a tag, you could potentially get something out of it, but you would know what you're comparing with.
Yeah.
Like all the numbers of people use different norms.
What about consistency? Like level of consistency of code, perhaps APIs?
Level of consistency. Can you give an example?
Perhaps, for example, let's say you have a REST API. Let's say you're using Swagger, for example, to document that API. With a Swagger document that explains your API, you should be able to programmatically traverse this document and determine places that could be consistent with your other APIs. For example, you can detect things like, perhaps, you know, there's certain things in the URI, for example, that might not be good, might be better. You should be able to take n number of APIs and compare them against one another with the metadata of the API using something like Swagger or Wisdom.
Interesting. So
Policy enforcement.
Exactly.
I was gonna say A/B testing, which is similar with exactly what you say.
So here's the general direction that I was kind of thinking of taking it. So I have a side effort since, like I mentioned, that, you know, I'm kind of working on trying to solve a different problem. But with the launch of my book, I'm also planning on launching Open Mastery, which is essentially a open mastery certification focused on clarifying kind of the art and decision-making knowledge and using this feedback loop as a system to teach and creating an open certification around those things. And so if let's just assume for a minute that everybody was monitoring developer experience data. So let's just throw that out there as a base assumption. Like if that would happen, like, and we had all this data out there for people's experiences with various APIs, then how could we solve the problem? Like, you know, it's like I realize there's kind of a critical mass problem, but that's why I'm going and evangelizing stuff and all that, and that if we have the data measured for all these different things that people were using, is there a way that we could kind of index the developer experience data out there to make it usable in this way? So that's why my main thought was, okay, let's organize things by use case. In that if one developer is building a hello world type app, and another one has another use case where they're merging things together and using some different APIs. If I'm out there looking for a component, I really only care about the developer experience things with the use cases that I care about. Everything else is kind of like, sure, that's painful, but I'm not going to be using it, so what do I care, right? For the use cases I care about, this is all that matters. And with any API, they're generally optimized around a certain set of use cases, and then they might have support for some other things, but often if you go outside of that box that it was built to really function for, some of the usage starts to get a little funky. It's like a bolted on feature kind of problem. So just imagine for a minute that we had this data across the board. Then how would you solve the problem? Because I feel like you guys are still thinking about how would we solve it without the data.
I think the problem in the API space today is the question of what do we measure is quite difficult. And some of the signals that you're referring to are things like when is threat coming in, or when are folks getting stuck on problems. The question is, how do you capture the start and stop of those things if you're doing some sort of user study or research on how people use APIs.
So the way in that model, I have very specific start, stop points defined with regards to measuring, troubleshooting, learning, and rework, and a kind of semi-standardized process for when those happen. I've had people mention to me about developers are never going to push buttons. How the hell are you going to get developers to push buttons? And one of the things that I've found is that buttons are really amazing with regards to practicing awareness. In that once we become aware of certain moments in time, then our brain, we can make conscious decisions as opposed to autopilot decisions. And having buttons is really helpful initially, even for building that habit of awareness. And then after that, after it kind of you get used to it, it's not particularly hard.
So it's sort of like a stoplight approach to I'm doing something and now I'm gonna hit the yellow light because I'm not quite sure what's going on, and then now I'm gonna hit the red light when I'm completely stuck.
Yeah. So
the green light when I figure it out.
Yeah, kind of like that. So in this case, I have those time bands. So the problem starts when you first run into the problem, and then you toggle a button to off when I probably should have set up a demo. I could show it to you then. Keith?
So one of the things we're tracking with our API, we're not doing anything with it though, is that when somebody starts using the API and start hitting 400 errors, we capture all the status codes so that we know they hit this many 400 errors, and then we keep track of once they stop hitting 400 errors with the assumption that whatever they're trying to do, they're doing it wrong or incorrectly or whatever, and now they stop doing it, which we hope means success. And we haven't done anything to take action on that, but we've been pondering things after an hour, if they're still hitting 400 errors, we send an email with, hey, it looks like you're having problems, do you want to send us a ticket? Something along those lines, but yeah.
So you're basically trying to solve the problem from I'm an API provider and trying to understand how my users are using the system and what they're struggling with.
Yeah, but then again, we're stuck that we're watching for the 400 errors. If they're trying to do something that's successful, technically, but it's not successful in terms of what they're trying to accomplish, we don't have a way of detecting that at this point.
So what if they sent you data that said, this was the error message that I had on my screen, and what I was observing at that moment I ran into a problem, And then here's all the things I kind of looked at along the way, and eventually I figured out, oh, this was wrong. This was the thing that I had screwed up. What if they shared the data of their troubleshooting experience with you?
I think that'd be fantastic. Yeah, I think that'd be fantastic.
Which is like the ideal Stack Overflow post. If you find one that's really good, it's somebody who's explained it.
That kind of Google Analytics for the app.
Yeah.
That kind of ties into what I was thinking of, is that if you've got like, you know, the data that you have around actually recorded user experience of like troubleshooting and progress and that sort of thing, if that's like very rare and very valuable, and then you've got this gigantic sea of data of all the source code available on GitHub, but you don't have that user experience data to go along with it, if you could sort of marry like the user experience data with the code that they were looking at the time,
Yeah.
and somehow use that to draw correlations,
Yeah.
and then you could take the result of that correlations and then start applying it to this giant sea of code and see if you could guess what the resulting user experience would be, or developer experience would be, with someone actually reading through that code and having to use it.
I mean, what you're describing is the traditional user study in UX, right? But just applied to somebody trying to make code work.
So essentially, I have those associations in here, in that it tracks the overall context of what everybody's looking at, in addition to the manual data kind of over the top. And if there's additional things that we need to track, I mean, I'm basically tracking file activity and when people are modifying things and how long they're staring at various files. But there's no reason you couldn't track execution activity and other kinds of things on top of that, and have kind of a background of, or whether tests are failing or passing, or all these other kind of state information. There's no reason we couldn't capture more information. So another potential approach would be to use this from a usability testing standpoint. So let's say I've got an API product, and I design a set of use cases that I'm planning on supporting with my API, and I go and get a bunch of developers to go and execute the use cases and then record their experiences and stuff. And then you just in the same way you do user testing for anything else, it'd just be a different way to gather and study the data. But you could make a deliberate effort to go and gather data for API certification. So like having so one of my thoughts with regards to an open standard too was you could potentially make a certification that is based on publishing a certain amount of data. So it's an open certification kind of thing that, like for example, if I wanted to get my sticker of approval, then for these particular use cases, I go and gather X amount of data and publish that to the public, and then I get my certification sticker for sharing this data. And then other folks in the community, if they wanted to augment that and publish additional findings, there'd be kind of a central hub where we could start kind of aggregating this information and provide enough of a incentive for people to do it, in that helps people to, like consumers, select stuff so that there's a selection bias against not having this public information. We have the secretive API. Nobody wants to be the guy that doesn't have the data when everybody else does. So that would be there's like Mastery starting to do developer experience certification stuff, but it's like this 12-week privatized thing that who knows what they actually do during that time. So, by the flip side, this would be, we're going to do a case study on our API, and we're going to publish all the information for public consumption. And regardless of what the results of that are, the certification is based on the availability of data, as opposed to a quality metric, like trying to judge the data automatically.
We walked in here tonight with the notion that developer experience meant developer portal. Anyone? I run into it constantly. I'll just say that it's refreshing to hear somebody thinking about it as a real thing. Because it's hard.
you have a tool for IntelliJ, and I guess you're thinking about putting it in Visual Studio.
Yeah, I mean, at this point, I have a reference implementation that I've been, using, with my team and on a limited basis. So once I have my book out, I'm going to make a version of it that's IDE agnostic, and then work with the community on porting it to different platforms and stuff. So it'll end up being available, even though it's not quite right now.
Well, tell it to GitHub to get in on it. All these IDEs work with GitHub pretty well.
I was gonna say build a Node.js command line. It'll get some use.
There's lots of hour trackers out there too. That's basically what this is, an hour tracker plus tags.
Yeah, we've actually talked about, since, some companies, they want you to enter in your hours and stuff, and it's just a pain to go and, fill out time tracking information. It's just awful. But, if you could hook up your IDE to submit it all for you and you didn't have to do it anymore, it's like, you can watch me all you want and everything and never have to time track stuff again. Wouldn't necessarily be too bad.
So there are all these tools out. I'd be interested in a tool that would support web development, like that hooks into like Grunt or Gulp or something like that. That can monitor. You have like file watching utilities and stuff that can monitor all those changes.
Well, as part of this, since you built the plugin around IntelliJ, it also means that going down the list of PyCharm, RubyMine, PostStorm, WebStorm, all those should support the plugin just fine.
Yeah.
Also just do a Chrome plugin like everything else.
That involves writing JavaScript though.
Yeah, but you gotta.
And we know how that goes. I'll just have Julia help me with that part.
Do you foresee, this probably sounds a little ominous, but I know sometimes in development environments, people can get, when it comes to a developer and, I have to learn this much, or I'm having problems with the code, especially when you're new and you're onboarding. And a lot of times, maybe you're working with a team that has a lot of experience with proprietary code and you're really struggling. And maybe you don't want anybody to know how much you're struggling or how much you don't know, or like how much you have to learn, or you're kind of trying to like, hey, I can handle this. You think that there might be.
I think that's probably the bigger issue is that personal sense of exposure. When of data collection and stuff, and even with my team where we had a trusting relationship and they were cool with collecting data, there was still this like almost like fear of looking in the mirror kind of thing, and I think as developers at some point in our career we have to learn to be okay with like critique and kind of dissociating our work with ourselves, but which is a natural response to the things we create feel like part of ourselves. And so when they get criticized, it feels like an impersonal attack. And so there's definitely a strong emotional component to get over with, and sharing this data at large is even more exposing than just doing it with your team. One of the things that happened to me with this whole experience is of bringing down production semiconductor fabs and stuff is that at the time that this happened, especially since like looking back on my decisions, I did some like stupidly risky stuff. Like I walked in on this job and kind of looked at this and went, I can fix this. And like literally, I'd been there like 6 months and I tore the application apart and put it back together again. It's just like stupid stuff that nobody should do.
So it seems like we have a million great questions that ought to just be chatted out. Are we almost there?
Oh, I'm done.
Okay, cool. Just making sure.
Yeah.
I was gonna say, because this seems like great chat stuff. but I know there's probably people who are
So-
doing, you know, husband and wife texts for dinner or something.
So one last slide essentially is my book slide. So if you go to newiron.com/tech stuff, I'm giving away free e-books until with my final draft of my book, and I could use some help with regards to kind of getting feedback on the final draft before I hit the official publish button and Amazon reviews and all that. So if you'd be up for being a guinea pig proofreader, I would really appreciate the feedback. And if you had thoughts about this topic, if you'd be up for thinking about it and blogging about it and sending me a tweet about it, I'd love to hear your thoughts too. All right, well, thank you guys.
All right, a couple of quick housekeeping things. First of all, who's hiring? Okay, if you could give us, stand up, give us 3 quick sentences. Here's who I am, here's who I work for, here's what we're hiring for. You wanna go first?
Oh, geez. I work for a recruiting company, and we're hiring for like pretty much everything, so.
Okay. Janelle KZ on Twitter, right?
Yep.
Okay. Next up, go ahead.
Also work for a staffing company. Mobile developers, specifically for any SDK experience, Android and iOS.
Okay, anybody else? Okay. Anybody else on this side of the room? Okay, over on this side of the room. I saw a few hands. Go ahead.
Yeah, my name's Troy. We're UShip. We're hiring developers C#, as well as mobile, iOS, Android.
There's JavaScript people too.
JavaScript as well. JavaScript people too.
I'm Jesse. I'm from Reserve Voice. We're looking for some front-end engineers, JavaScript people.
I'm Adam from Rework, and we're looking for PHP and JavaScript people.
Anybody else? Go ahead.
Yeah, you get stash logistics, C#, but you can't build it.
Anybody else? I'm not going to ask who's looking because sometimes you don't want that to be public. So, but look around at the people who are hiring. That's great. So, anyone have a tool that they discovered in the last month that they want to share about? We'll do time for 3. Anybody? Awesome tool. Awesome concept you learned. You're like, oh my god. You have one?
A tool that me and my business partner created, and trying to get this product up off the ground. Addressing a lot of what she's talking about right now, called dynamic APIs.
Okay, and we can Google dynamic APIs and find it? Yep. Are you sure?
Yeah.
It's a.
It's the only result.
It's the only result.
We just launched our data like 3 or 4 months ago. So.
Okay, cool. Anybody else? We got time for 2 more. Go ahead.
We've recently at UShip been starting to use, at least on my team, a tool called PAW. It's a.
How do you spell that?
PAW. It's an alternative to Postman or what's called.
It's awesome.
Yeah.
Okay, there we go.
It can generate code to hit an endpoint that you set up in different languages. It uses extensions, so you can add more extensions to export types of code.
Fantastic. I'm going to take the last one. I found an awesome tool called Slate. It's for building developer portals. So developer experience is way more than just the portal, we know, but getting the code in front of people, being able to build that. It's from a company called TripIt. If you use TripIt travel stuff, go to, on GitHub, go to TripIt/Slate, and you can find that. It's a great tool for doing a lot of stuff. Just discovered it about a month ago. We're not using it yet, but we're planning to. So anybody else? Closing comments? Okay, so don't forget, API strategy and practices conference will be announced formally tomorrow. So Google that. I think the site's supposed to go online tomorrow officially and everything. But in the meantime,
API strat.
yes.
I go on Twitter, it'll all pop up tomorrow, and probably lots of answers.
And of course, follow Austin API on Twitter, and we'll share the news. Thank you everybody for coming tonight. You don't have to go home, but we have to be out of here in about 20 minutes. So feel free to hang around and chat, but 9 p.m. we have to step out. All right, thank you everybody.